All right, we are on our last example on page 4, and it has given us a general form or a standard form, or it's just an equation. We have to figure out what the heck it is. Since this is hyperbola notes, it's my guess it's hyperbolas. But what you want to do is you want to put all your x squares together, your x squares and x's, your y squares and y's, all your numbers on the other side, complete the square, find your center, do all that business. So, first thing I'm going to do is figure out which one's positive. The y squares are positive, right? Mm-hmm. So I'm going to put those first. 3y squared minus 12y. I'm going to leave some room. Minus, I'm going to go ahead and put it in parentheses here. 4x squared plus 8x. I'm going to leave some room. And I'm adding 4 to both sides. So I get equals 4 over here. So far, so good? Mm-hmm. All right. Now you can take another step to get there if you need to, but that's good enough for now. When you're looking at your standard form of a hyperbola, the inside never has a coefficient in front of the y, so we have to get rid of that, so we have to factor these out. So we're factoring out a 3 here. 3 times y squared minus 4y, and then I need to finish completing my square here. So, do you remember how to do that?
Mm-hmm. Yep.
So here's my y squared. This would end up being a negative 2y and a negative 2y. So what is that?
4.
Y, negative 2, negative 2. So I'm going to have to add 4, right? Mm-hmm. Add 4. But I didn't really add 4. What did I really add?
12.
3 times 4, which is 12. So over here, I'm going to add 12. Are you okay with that?
Yep.
All right, I'm going to go ahead and write this as a perfect square before I move to the other side. 3 parentheses y minus 2 quantity squared, and then minus. Remember, the y minus 2 comes from the side of the square that we made when we were completing it. Mm-hmm. All right, on this second portion here, I need to factor out something from my x's. What do I need to factor out?
The 4.
4. So I'm pulling a 4 out. So 4 times, this becomes x squared plus, what is that, 2x? Mm-hmm. And do you remember how to complete the square on that one?
Yeah.
Take half the middle, which would
squared,
be
which
1.
is 1 squared, which is 1.
Which is 1, so I'm going to add 1. But I didn't really add 1. What did I really add?
4.
Not really.
Well, negative 4, actually.
Okay, so what am I having to do over here?
Add
a negative 4.
Oh, yeah.
Okay? Mm-hmm. So if we rewrite this, it's going to be 4 parentheses x plus 1 quantity squared. Mm-hmm. And that's going to end up equaling 12 if we did it right. So far, so good? Mm-hmm. Mm-hmm. Now, in the standard form of an ellipse or hyperbola, what do they always equal?
1.
1. So what do we have to divide the whole enchilada by?
12.
12. So I'm going to put this over 12. I'll put this over 12. I'll put this over 12. This becomes y minus 2 quantity squared over 3 goes into 12 how many times? 4.
4.
Minus x plus 1 quantity squared. 4 goes into 12 how many times?
3.
3 equals 1. Now, from this equation, we should be able to tell, well, and you want to write your final equation down there where it says equation, but you should be able to tell just by looking what the center is. What is my center?
Negative 1 comma 2.
Yep. Negative 1 comma 2. Ah, you got it this time, right? The h always goes with the x, y always goes with, it's not which is first, just remember what goes with it. Transverse axis length, do you remember what the transverse,
It's the square root of under the first term times 2, right?
So this is the a square, right? So a squared equals 4, no, a squared equals 4, what is a?
2.
2, what is 2a?
4.
4. That's going to be your transverse axis length. Okay, it's not equal to the number under there. It's twice the square root of that number.
Okay.
Which is right. I wrote down the a square and the a, so you would see.
Mm-hmm.
Okay?
Yeah.
Alrighty.
Make sure I get that. See, it's right there.
See, it's right down there.
Isn't that amazing?
Right.
Okay.
We are on page 5 of Hyperbolas, and it says write an equation of a non-rotated hyperbola, which is all we've done up to this point. If it's rotated, it will have an xy term in it. Okay, ours just has like, we just do the x squared, y squared ones, okay? But if you're looking at the general form, somewhere in there you'll have an xy term. If you see something like that, it's still second degree, but that's what does the rotating.
Are we ever going to do
We
any
are
like
not
that?
doing rotating here, but if you do it, if you go higher along, you will get into rotated hyperbolas.
Okay.
Okay? The information it gives us is it says one vertex is going to be at negative 8, 0. The other vertex is at 8, 0. Remember how we talked about making a little bit of a graph to kind of help us here? So if I did that, it doesn't have to be perfect, but okay, negative 8, 0 is going to be about over here. 8, 0 is going to be about over here. Oh, those are my vertices. That means my hyperbola is going to have what? They're going to open out this way, right?
Yep.
I don't know how fat or wide. I just know they're going to be that way. Okay? Can I tell what the center would be?
Yes.
Just from looking at it?
0, 0.
Okay, this one's kind of an easy center. If I couldn't see it just by looking at it, I could use the midpoint formula and come up with whatever it is. Okay, so my center is going to be at 0, 0. What is the distance from the center to a vertex? What's that
8.
called?
8.
And that's A.
Okay, it is. The distance is actually 8, and it is actually A. So
It's
A
A.
is 8. Perfect.
That's great. Sorry.
No, I'm loving every minute of it. Okay, now let's see. What other information did it give us?
It opens side to side.
Who's
There's
asymptotes? Y
The
equals 4/3 x and y equals negative 4/3 x. Is that making sense? Yes, no, maybe?
Yeah.
Okay.
It's an equation of a line, which is asymptote, which shows how wide it is open.
Exactly. And so if we're looking at positive 4/3 and negative 4/3, that tells me my well, let me just hold on a second. Okay, the horizontal here is the A, so the B is on the top. Is that making sense?
Uh-huh.
So it's like y equals b over a x. That's what I'm trying to get. Okay. I actually know b over a is equal to 4/3, right? Because they gave me the actual equation for the asymptotes.
Yes.
So far, so good.
Oh yeah, the center's 0, 0.
Okay, center 0, 0. That's where we're getting it. And I was just drawing this because I know that A is here, but it's easy for me when I'm looking at a line to think of slope as being vertical over horizontal, so I'm trying to get it all worked out in my brain here. So 4/3 equals B over A, but I already know what A is, don't I? Okay, what is A?
8.
Okay, so B over 8 equals 4 over 3. So that gives me B equals 32/3, because I multiply both sides through by 8. Yes?
Yes.
Okay, so B is 32/3. So let's see. I think I have everything I need. I have an A, I have a B, and I have a center. So I ought to be able to write my equation.
Yes.
So if I write my general equation, oh, which way does it open? Because it
Side,
matters,
side.
right? So what's going to come first, the x or the,
The
y?
X.
X. So x minus h quantity square over a
So that'd
squared
be x squared.
minus,
Because center's 0, 0, right?
Yep.
yeah. I was just writing the general one first.
You're getting
But no, you're better and smarter than I am. X squared over, what is that, 64? Minus y squared over, what is 30? I'm just going to write it as, you're going to love this, 32/3 quantity squared equals 1.
Yay! Is
Some
it
of them
legal
are.
to have a fraction underneath in the denominator of the
It's
fraction?
fine with me. In
Okay.
this kind of format, today,
It'd be 1024 over 9, I think.
yeah, and that's probably the way you'd want to do it. Yes, you do not want to turn it into a decimal or anything that's unexact. So you'd rather write it as a fraction than try to convert it to something that's not exact.
Okay.
Okay? All right, and that's going to do our hyperbolas. All righty. Thank you. Now, there's more on hyperbolas, which is rectangular, but I'm not going to go into that.
On the positive.